Hi, I'm Barry Walsh, your COVID-19 Math 10 teacher. Today's lesson is on parallel and perpendicular lines. Today we are going to focus on slope and only slope. The first thing that we'll do is look at a couple of parallel lines. Number one, my original line, I'm going to make it with a slope of 2. You see what I'm doing here? Right 1 up 2, right 1 up 2. So I will draw my line, and then we'll get to a parallel line. Okay, so there's my line. We already worked it out. And the m is equal to 2 over 1, or just 2. Are you okay with that? Right 1 up 2. Now let's draw a line that is parallel to that one. We can start anywhere. Let's start here. Right 1 up 2. Right 1 up 2. Right 1 up 2. So I want to use a ruler. I don't want to make a mess. Okay, there we go. What is the slope of that line? Well, it's the same as the first line. M from y equals mx plus b is equal to 2, or 2 over 1. You can say 2 over 1 if you want. And let's do one more. Let's draw a third line parallel to both of those, and we'll start it down here. Okay, just trying to use the ruler so I don't make a mess. There we go. And once again, we have a slope of 2. So that is the first mini lesson for today. Parallel lines have the same slopes, or equal slopes. Now you can calculate, we'll get into calculating the slope in a couple of minutes. But for now, I just wanted to count spaces, right up, right down, and so on. That's the easiest way to get the slope if you have a nice graph. Now, one of the things I noticed about my diagram, so this one looks pretty good. But what I noticed is, because I have homemade graph paper here, with some of my diagrams, they don't look exactly the way they should. And homemade graph paper is better than none, but I really urge you guys, I said this before, get graph paper and use it. You just will save yourself massive headaches. Okay, so parallel lines was our first graph. Now, perpendicular lines. What I'm going to do is start off with the same line that we started with over here. There it is. I'm using that ruler again because I don't want to make a mess. Okay, so m equals 2. Agreed? 2 or 2 over 1. Now, what if I draw a line that's perpendicular to this line? Okay, I'm going to do that now. I know where it has to go, so that's what I'm doing. Now, because of this homemade graph paper I have, that might not look like it's perpendicular, to the original line, but it is. Now let's look at this slope. Let's look at the slope of the perpendicular line. Maybe I could make it go a little further down here. No, I don't have to. Okay, so what happens here with this slope? The slope of this line is m is equal to, let's start here and count spaces. So we go right 1, 2, and down 1. The rise is -1 and the run is 2. You see that? Right 2, 1, 2, and down 1. Rise over run, -1 over 2. Now I'm going to draw another line perpendicular to the original line. And I'm going to do it from here. Okay, so here we go. And again, I have homemade graph paper on this. It doesn't look like big paper, but this is huge. It's like 2 feet wide here. Okay, so this is going to be the same as this one. Watch. Right 2, down 1. So the slope, m in y equals mx plus b, is -1 over 2. The original slope is 2, or we can call it 2 over 1. Might make it easier if we call it 2 over 1 for this explanation. Okay. Perpendicular lines have slopes that are, hope you can make out my writing, that are negative reciprocals. I have to spell this right. Reciprocals. Perpendicular lines have slopes that are negative reciprocals of each other. Okay. Now, that's a mouthful, I understand. I'm going to switch to green for a minute. So the original line had a slope of 2, or 2 over 1. And the first perpendicular line we drew has a slope of -1/2. Now, what is a negative reciprocal? We'll take a look at a couple of these. For a negative reciprocal, you take the original slope, flip it over, flip it upside down, and change the sign. Negative reciprocal. Flip it over and change the sign. A lot of people at first, they remember to flip it over, but they forget to change the sign. Okay, let's look at another one. Say we had -3/4 as our original slope. What would be the slope of a line perpendicular to the original line? Flip this over, so you get 4 over 3, and change the sign from negative to positive. Let's do one more. What about if we had 3 over 2? 3 over 2. What is the negative reciprocal of 3 over 2? Flip it over and change the sign. There you go. So 2 over 1 and -1/2, those are the slopes. These two lines would be perpendicular to each other. These two would be perpendicular to each other. These two would be perpendicular to each other because the slopes have that relationship. They are negative reciprocals of each other. Okay, now let's look at number 3 down here. I'm trying to not to put too much on one page. Now, this is a parallelogram, or it's supposed to be. And hopefully you guys remember what a parallelogram is. Can you think of a definition just as I'm about to write it down? Can you remember, maybe from junior high, what a parallelogram is? Well, the first thing is it's a four-sided figure. Another name for four-sided figure begins with Q, quadrilateral. It's a four-sided figure with opposite sides parallel. Parallelogram, four-sided figure with opposite sides parallel. So, parallel. Immediately, you should be thinking about slopes, and you should be thinking about opposite sides having the same slope. Doesn't mean all four sides are going to have the same slope, opposite sides. Okay, we'll calculate them down here, but first, let's look and see if we can figure them out by looking at the graph. If you have a good graph, you should be able to figure them out from the graph. Okay, let's start here at AB. Okay, so what is the slope of AB? All right, we go to the right 1 and up 1, 2. Rise is 2, the run is 1. Right 1, up 2. I'm going to circle this, make it stand out. Now let's go to the opposite side of AB, which is DC or CD. Okay, so if we start here, we go right 1 and up 1, 2. Hey, it's the same as this one over here. Right 1 and up 2. So the rise is 2 and the run is 1. We have 2 over 1. Now, what does this tell us? It tells us, because these are slopes, remember over here at number 1, if the slopes are the same, then the lines are parallel. Definition of a parallelogram, four-sided figure with opposite sides parallel. So we have 2 parallel sides right here. Now we have to check the other 2 sides to see if they're parallel. You never just look at something and say, yeah, it's a parallelogram because it looks like a parallelogram. No, you have to do the math. I like that expression, do the math. Okay, let's get this one, AD. So this one goes to the right, 1, 2, 3. Right 1, 2, 3, and up 1. So the rise is 1 and the run is 3. I'm going to circle that. And the side opposite, AD, is BC, so we'll do this one up here. What is the slope of BC? Okay, start right here at B. 1, 2, 3 to the right, and 1 up. That's rise over run, 1 over 3. So what does it tell us about these 2 sides? The slopes are equal, therefore these 2 lines are parallel. So we have opposite sides in this four-sided figure. Opposite sides have equal slopes, therefore opposite sides are parallel. Therefore, this is a parallelogram. Now I'm going to do the calculations, just so that you'll see that when we calculate, we get the same thing that we did when we did it from the graph. Formula for slope, y2 take away y1 over x2 take away x1. All right, we'll start here with AB. Now when I do, I'm not going to write out this formula every time. This is my first point because I'm starting here. This is my second point. So x2, y2. So for the numerator, I'm going to have 2 take away 0. y2 take away y1. So 2 take away 0. And then negative 1 subtract negative 2. That gives us 2 in the numerator, and that gives us negative 1 plus 2 in the denominator, which is equal to 2 over 1, or just 2. All right, so does that confirm it? Yes, because on the graph, when we counted spaces, we got 2 over 1, and when we calculated, we got 2 over 1. I'm not suggesting that you have to do this. You don't have to do it both ways. But sometimes you're going to have to work with slope and you're not going to have a diagram. So you're going to have to work it out. So you have to be able to do it both ways. Okay, now BC. This is x2, y2, x1, y1. It is so easy to make a mistake when you're doing this. You have to be so careful. Okay, so y2 take away y1 is 3 take away 2. I'm going to draw a line here so we don't get it all squeezed together. Okay, 3 take away 2 for the numerator. And for the denominator, 2 subtract negative 1. 2 subtract negative 1. Now that gives us 1 over 2 plus 1, which is 1 over 3. And that's what we got when we did it by looking at the diagram and counting spaces. Okay, CD. This is going to be my x2, y2. So, I didn't give myself much room here, did I? Okay, so we're going to do y2 take away y1, which is 1 subtract 3. I'm sorry about this, guys. I made it too small. 1 subtract 3 for the numerator. And for the denominator, it is going to be 2 subtract 1. 1 subtract 3, no, it's 1 subtract 2, I'm sorry. Okay, 1 subtract 3 and 1 subtract 2. y2 take away y1, x2 take away x1. Okay, so that's going to give me negative 2 over negative 1, which is equal to positive 2 over 1 or positive 2. And that's what we got when we counted spaces on the diagram. And the last one is DA. So this is going to be my x2, y2. This is going to be my x1, y1. Okay, so for the numerator, I'm going to have 0 subtract 1. And for the denominator, I'm going to have negative 2 subtract 1. And that gives me negative 1 over negative 3, which is a negative divided by a negative is a positive, so we just change this to positive 1/3. And that's what we got up here when we counted spaces. It's so easy to make a mistake when you're calculating slopes. You have to be so careful, especially when you have double negatives. Believe me, it's easy to make mistakes. Okay, so that's the first part of the lesson. I'll be right back with part 2. Okay, let's take a look at diagram and question number 4. So this question, it's a common question that you would be asked in grade 10 and beyond. Is this a right-angled triangle? You can't look at it and say, yes, I can tell by looking at it. No, you have to do the math. I love saying that. Okay, now what you can look at and say is that, well, if there's a 90-degree angle in this triangle, it's not there. That's too small. That one, it can't be that one. That's too small. If there is a 90-degree angle, this would be the one right here. So what we have to do is we have to look and find the slope of this side, and we have to look and find the slope of this side. And if the two slopes are negative reciprocals of each other, that means the two lines are perpendicular. And when two lines are perpendicular, that means there's a 90-degree angle right there. So we just have some calculations to do. So what we're going to do is we're going to do it on the diagram, and then we'll do the calculation. Okay, so let's look at AB. We don't have to bother with these other sides, this other side at all. Let's look at AB first, and then we'll do AC. Okay, so if we start here, what is the slope of AB? All right, so it goes right 1 and up 2. Right 1 and up 2. So the slope is 2 over 1. Rise, up 2. Run, over 1. Now let's look at this one. If we start here, and we're counting spaces, what's the slope of AC? Okay, so we go right 2 and down 1. So the rise is negative 1, and the run is over 2. Over 2, down 1. So there we go. So look at these two slopes. Are they negative reciprocals of each other? Take this slope, flip it over, and change the sign. Do you get negative 1/2? Yes, you do. Therefore, we know this is a 90-degree angle because these two lines are perpendicular. Well, that's not too bad, is it? All right, so let's do the calculations. Just so that you'll see what it's like doing these calculations. Okay, so this is going to be my x2, y2. I'm going to do this side first, AB. X2, y2, x1, y1. Now this one doesn't have any negatives in it, so it's going to be pretty easy. So y2 take away y1 is going to be 5 take away 1. That's the numerator. And the denominator is 3 take away 1. x2 take away x1, 3 take away 1. That gives me 4 over 2, which is equal to 2 over 1, or 2. Now let's do AC. So this will be my x2, y2 here. Even when I don't write this down, I do it in my head. So I know this is x2, y2. So I'm going to have negative 1 subtract 1. Negative 1 subtract 1 in my numerator. And in my denominator, I'm going to have 5 subtract 1. So that gives me, on the top, I get negative 2. 5 take away 1 is 4. And then I reduce this, I get negative 1/2. And these are the same as we got up on the diagram when we counted spaces. Pretty neat, eh? So if you did not have a diagram, you'd have to do it this way. I suppose you could draw a diagram, but sometimes diagrams, especially if you have large numbers and you have to figure out how you're going to draw it, and maybe you don't have graph paper, and so the calculation is important. Okay, so our last question today is a rectangle. Now, what is the definition of a rectangle? Well, I'm going to a different color again. I'm going to go to red. It is a four-sided figure, quadrilateral, the Q word, a four-sided figure with four 90-degree angles. Now, I think that's the easiest definition. So, all we have to do is show that connecting lines, connecting sides, have negative reciprocal slopes. So if the slope of this side and the slope of that side have negative reciprocal slopes, then that's 90 degrees. And we have to do that all the way around. It's not really hard. You just have to take your time, because it's a little bit more complicated than this one over here, where we only had to do one angle. Okay, so first let's do counting spaces on the diagram. Okay, so let's start here, and if we count spaces, okay, so we go to the right, 1, and down, 1, 2, 3, 4. So rise over run minus 4 over 1. Right 1, down 1, 2, 3, 4. Rise and the run. Okay, so for this one, we can just do these four, and it's the same from here to here as it is from W to this point. I didn't name this point. Not necessary. Okay, so let's count spaces. 1, 2, 3, 4. 4 to the right and 1 up. Rise is 1. Run is 4. There we go. Are these two slopes negative reciprocals? If you flip this over and change the sign, do you get 1/4? Yes, you do. So we know this is a 90-degree angle. Remember, I told you a while back that my graph paper is homemade, so this might not look like it's 90-degree angles. But because I had the slopes calculated, I know it is. Okay, let's do this side. It should be the same as this side. Let's see. Start here, right 1, and down 1, 2, 3, 4. Okay, so minus 4, that's the rise, and the run is 1. Right 1, down 4. 1, 2, 3, 4. So I'll circle that one. Now that's a negative reciprocal to this, so now we know that this is 90. Even though on my homemade graph paper it might not look like it, we know it is because these slopes are negative reciprocals of each other. Okay, let's do this one. We only have one left. Okay, I'm going to start here, and I'm going to count spaces. So I'm going to go right, 1, 2, 3, 4, and up 1. 1, 2, 3, 4, and up 1. Rise is 1, run is 4. Okay, so now this slope, negative 4 over 1 and 1 over 4, they make up this angle. They are negative reciprocals of each other, therefore this is a 90-degree angle. And the last angle, we have to look at these two connecting lines, the slopes of them. They also are negative reciprocals of each other, therefore this is 90. If we have four 90-degree angles in a four-sided figure, we have a rectangle. Okay, so we showed that this is a rectangle. Now, one of the things you need is a definition of these things if you're going to figure out if something is a rectangle or a rhombus or a trapezoid. And these are words, if you can't remember them from junior high, you can Google them, look them up, and that's just the way to go. You have to have a definition before you can show that something is a rectangle or a trapezoid or a rhombus or a square. Okay, let's do this part. And remember, we've got negatives here. Three of the points have negatives, so we have to be careful. I'm going to start here. I'm going to do ZW, so that this is going to be my x2, y2. All right. Y2, take away y1. 1, subtract negative 3. Y2, take away y1. X2, take away x1. Negative 6, subtract negative 5. Okay. So I get 1 plus 3 over negative 6 plus 5. That gives me 4 over negative 1. And that's the same as we got up here. You can call this negative 4 if you want to. But when you're doing negative reciprocals, it's nice to have the full fraction. Okay, ZY. Okay, I was going to go around clockwise, so I'll go clockwise, counterclockwise, because this is the way that I set it up here earlier. Okay, so ZY, this is going to be my X2, Y2, and this will be my X1, Y1. Okay, so for ZY, for my numerator, minus 1, subtract negative 3. And for my denominator, 3 subtract negative 5. That gives me negative 1 plus 3 over 3 plus 5 equals negative 1 plus 3 is 2. 3 plus 5 is 8. And I can reduce that. If you reduce 2 over 8, you get 1 over 4. Is that what we got here? Yes, it is. Okay, so far, I'm on the right track with my calculations. Now I'm going to do this one, yx. So I'm going to make this my x2, y2. And for the numerator, I will have 3 subtract negative 1. And for my denominator, my x values, 3 take away 2. So that's 3 plus 1 over 1. Okay. So what did I do wrong? I did something wrong. I have to try and find my mistake here. Okay, so 3 subtract negative 1. Okay, that's right. And then 2, so okay, so I did it backwards. I should have done 2 take away 3. And that would give me negative 1. And then that would give me 4 over negative 1, which is negative 4. So this is correct. See what I did there? It's just a careless error. Okay, so the last one, XW is up here. This will be my X2, Y2. This will be my X1, Y1. So I will have 1 subtract 3 for my numerator, y2 take away y1, and then x2 take away x1. Negative 6 subtract 2. So 1 subtract 3 is negative 2. Negative 6 subtract 2 is negative 8. Now when you have a negative divided by a negative, it's going to give you a positive. And then we will reduce this. 2 over 8 is 1 over 4. And that's what we're supposed to have because that's what we got up here when we counted spaces. It is so easy to make mistakes when you have negatives involved in slopes, so be really careful. That's our lesson for today, and your homework that I would like you to do, it's in your book, page 349, 350, 351. Please do. 3, 4, 5, 6, 8, 9, 10, 12, 14, 16, 17, 18, 22, and 24A. And don't forget, if you get stuck, you need some help, send me an email, barrywalsh@gmail.com, and my first name is spelled B-A-R-R-I-E, walsh@gmail.com. You guys have a great day.